Most systems treat access control like simple configuration problem, but in reality, it's one of the highest risk decision inside any organization. So I built something different, a system that doesn't just manage access, but controls how decisions about access are made. Imagine this, you're part of a company and suddenly someone changes access permissions. But here's the problem. You don't know who did it. It could be an internal admin, it could be a careless change, or something completely outside your system. And then suddenly, employees start seeing sensitive data, critical systems start breaking, or worse, nobody even knows what changed. And when something goes wrong, there is no visibility. You can't clearly see what changed. No rollback. Once it's done, you can't undo it. No accountability. No clear record of who did what. No audit trail. And this is what happens when governance is not treated as a system. Now imagine something different. Imagine a system where every change is simulated before it happens. Every risk is measured. How many players are being affected? What the consequences are. Every decision is approved by right authority, and every action can be safely rolled back. That's exactly what I built. And this is not just a project, this is a governance control plane. Let's simplify this. What this system really does is control who can do what inside an organization, but in a structured, safe, and intelligent way. So instead of directly changing permissions, we treat governance like a life cycle. Simulate, we evaluate, we approve, we execute, and roll back if needed, which means nothing happens blindly. Everything is tested, validated, and controlled. Think about how we handle code. We use Git for versioning. We use CI/CD for safe deployments. Now imagine applying the same idea to permissions and policies. That's exactly what this system does. Now let's talk about the real problem. Most systems today have some major flaws. Direct changes. Admin changes directly modifies permissions. There is no safety layer, no simulation. Before making the change, you don't know who gained access. You don't know who loses access. You only find out after it's already live. No risk awareness. Every change is treated the same, even dangerous ones. Weak approval systems. Approvals do exist sometimes, but they are informal, unstructured, and not really enforced. No proper rollback. And if something breaks, rollback is either manual or just not possible. So what happens? Governance becomes unpredictable, risky, and fragile. So instead of treating governance like configuration, I started treating it like something else, an engineered lifecycle where every policy must go through strict stages. First, draft, then simulation, then approval, then execution, and rollback if needed. No shortcuts, no direct changes. Let's break this down in a simple way. TMS, Tenant Management System. This is basically a system that manages multiple organizations on a single platform. What is a tenant? A tenant is just one organization. For example, one tenant could be a school, another tenant could be a hospital. Each of them has their own users, roles, and policies, and they are completely isolated. I mean, the school can never access the hospital data, and the hospital can never access school data. Let's make this more real. In a school system, the admin could be a principal, a manager could be a teacher, and a user could be students. And now in a hospital, admin could be a CEO, a manager could be doctors, and user could be staff like nurse or junior doctors. Same structure, but completely different organization. Now here's where things get interesting. Let's say in the school, a teacher proposed a change. Students can modify their own marks. It sounds small, but it's actually very dangerous. Now instead of applying this directly, the system steps in. It simulates the change. It calculates how many students are affected. It evaluates the risk. And if the impact is too high, the system could block it or escalate it before it ever goes live. So even a small mistake cannot silently break the system. And this applies to every tenant, whether it's a school, a hospital, or a global company. Same structure, same control, completely isolation. Now let's talk about how the system actually controls access. It uses hybrid model. First, role-based access control. This is simple. Access is based on roles. In our school example, a principal would have full access. A teacher would have limited control. A student would have basic access. So your role defines what you can do. But roles are not enough. That's where attribute-based access control comes in. Now, access depends on conditions. For example, a teacher can modify their own marks only if exam is still active or only for students in their own class. So it's not just who you are, it also what the situation is. You might be wondering, why am I using two models? So RBAC gives structure, ABAC adds context. Together, you don't just control access, you control it precisely. Even someone has a role, they still can't act outside the rules of the system. Now, instead of applying changes to everyone at once, you can roll them out gradually. Maybe 10% of the users first, then 50%, then 100%. Why? Because this lets you detect issues early, and if something goes wrong, you can stop immediately. The system also gives you visibility. You can see total policies, active policies, pending approvals, risk distribution, and rollbacks. This system follows zero trust principles. There is no public signups. Access is invite only. Every request is validated and every action is logged. If you heard of AWS IAM, this system is inspired by that level of control. But it goes further because here you also get simulation before execution, risk-based approvals, and rollback capability. So you can think it as AWS IAM, policy simulation, approval engine. If you found this interesting or want to explore the system, feel free to connect with me. This is the governance control plane. So instead of treating governance as configuration problem, we treated it as a life cycle. Simulate, evaluate, approve, execute, and roll back. And this is just a theory. We will step into the system and see how this actually works in a real organization in the next upcoming video.